So remember, the best thing to do is to simplify the radical in the denominator first. So you're going to write the square root of 4 times the square root of 2 times the square root of x. Is this clear? Then this is 2. So I have 3 over 2, the square root of 2x. And now I know that I have to rationalize. And I have to rationalize using the same radical, the same index. Now, how many 2's do I have? Well, I have 1, 2. I need one more. How many x's do I have? 1, but I need a total of 2 because the index is 2. So I need another one. And that's final. So the top is 3, the square root of 2x, and the denominator will be, this product is exactly what I want, 2x multiplied by 2. So I have 4x. I recommend always simplify first and then try to find the portion that needs to be rationalized and then rationalize it by what it needs instead of trying to multiply and divide by the square root of 8x. I don't think that that's the best way. And if you do it like that and you rationalize using the square root of 8x, then you will have to simplify at the end.
Thank you.
Sure. That's what I recommend. Next question. Anything else? Anything else? I would like to work on our chapter 6. So let me show you where we are and what we're trying to do. So the next unit is a short unit. We will review chapter 6. Hopefully we'll do it in 2 hours. And then we have 6 sections in chapter 11. And then we are going to have our test. I'm hoping to have this test on the 9th of November. We'll see if that can happen. Also, you promised to give me 15 minutes today, right? So we will finish at 8:30. Okay. I did get to my meeting, however, it was almost done. By the time I got there, there was a huge traffic jam. There was a big accident.
What do you do as a volunteer?
I am an exhibit guide.
Oh, that's fun.
Yes, it really is.
What animals do you
Yes. I'm sorry.
like? What animals do you like?
Well, what animals I like? I like the freshie. Freshie is the croc from Australia, and the Australia exhibit, which I like very much to watch him. There are 2 in there. I like the archerfish because I demonstrate mostly to kids that if I have an insect on a stick, they spit water to knock the insect off of the stick, and they eat the insect. Yes, it is archerfish. Yes, most of the time they don't miss. Yeah. That's in the Australia exhibit, and all the Shark Alley is a wonderful exhibit. Wonderful exhibit. They have a little show from BBC on sharks, and it's in 3D. And the theater seats have. Have you been there? Yeah. Yes, the seats move, and like you're in the water, and they spit water on you. You sit there, and all of a sudden you have water all over you. Yes, yeah. Yeah, it's wonderful. It really is. But we can talk about it later. So now let's. So you have the handout, right? Everyone has the handout. Yes. Okay. So yes, did you have other questions for me? Okay, so this is the entire chapter 6. I never present chapter 6 in the order the book is presenting it because I don't think it's the correct order. So we are going to look at factoring binomials, trinomials, and polynomials. Okay, totally separate. When we finish with binomials, we move on through this. And then we'll look at applications. What do we do with factoring? We've seen a lot of applications on factoring so far. We used the formula for a plus b times a minus b in two situations in chapter 10. What situations am I referring to? A plus b times a minus b. In rationalizing denominators, and similarly in dividing two complex numbers, right? We used a plus b times a minus b. Okay, now also factoring is used in the entire chapter 7. We will not be able to make any headway in chapter 7 when we get to it, which is here in unit 4, all chapter 7, if we don't review chapter 6. Okay? Very good. So let's start our strategy with factoring binomials. Yes? I'm sorry. No, this is the last one I had, but I can give it to you when we finish. You don't have it with you, or you lost it? It's already posted also. You can print it out, or you can have this one after I finish tonight. Okay. Very good. Factoring binomials. What is a binomial? Well, it's something like two terms, right? So, for example, if I copy this first example, negative 2xy to the 5th plus 3x cubed y to the 6th, this is a binomial. Two terms. Okay. In the strategy, I have the following steps. For binomials, I have 5 steps. In step number 1, and the first 4 steps go very quickly. Okay. First step, I'm asking myself, what is it? What type of polynomial? And the answer would be binomial. In the second step is it in descending order? Is it in descending order? In step number 3, greatest common factor. If there is a greatest common factor, I have to factor it out. In step number 4, negative leading coefficient. These, bless you, these two can go together if you want. 3 and 4 can be done together. Number 5 is special product. Actually, special products. And this, there are 4. A, B, C, D. And we have to talk about all of them. So if you're just giving me this polynomial, I will first say, what type is it in my head? All these 4 questions go quickly. So what type is it? Well, I see it's a binomial. Then I'm asking myself, is it in descending order? And I'll say, no, it's not, because the degree of this term is, I add up the powers of the variable, or variables, 1 plus 5, so degree 6. What is the degree of this term? 3 plus 6, 9. So this binomial has degree 9, so it's not arranged in descending order. So I will do it right now. I'm sorry? Number 1, what type of polynomial? And we have 3 answers. These are the 3 possible answers. It's either a binomial or a trinomial or a polynomial. So I will rearrange this polynomial as 3x cubed y to the 6th minus 2xy to the 5th. And then I reached question number 3, greatest common factor. So is there a greatest common factor here? And I can put together negative leading coefficient. This is the leading coefficient because it belongs to the leading term. So the leading coefficient is not negative. So all I care about is now a greatest common factor. So do I see a common factor or common factors present in both? The answer is yes. I see x in common and I see y in common. The question is what power? So x is in common here and here. They have the same x. power 3 and power 1. I always have to choose the smallest of the two. Now I see why. Power 6 and power 5. Yes, and I have to use power 5. Since I started with a binomial, I must have two terms in parentheses. Mandatory. So what is left? Such that this times this is 3x cubed y to the 6th. It's definitely a 3. I have an x, but here are 3, so it's x squared. I have a y to the 6th and y to the 5th, so this must be a y. Then I reach the negative sign, and xy to the 5th, so it's minus 2. So this is a typical example in which I didn't have anything else to do but just factor out the greatest common factor. Now there is another example in the same situation with x plus 2y times x minus 1 plus x plus 2y and x minus 2. And you can say this is no binomial. And I will have to say that you are correct and also incorrect. It can be looked at as two terms, a product plus another product. You can also say, but what if you distribute? And then I will have to say you're right in that case. X times x squared, x times negative 1, 2y times x, and 2y times negative 1. There will be 4 terms, and then 4 terms here, so it's not a binomial. But I can look at it as being two terms. And I see that they have a common factor. So we will both be correct and incorrect at the same time, right? So I see a common factor, which is x plus 2y. And then what is left? X minus 1 is left from the first term, and x minus 2 is left from the second term. But yes, I have to combine like terms in parentheses, and I will get x plus 2y, and then 2x minus 3. So in this example, I didn't have anything else but just to observe that there were two binomials, two products, and two terms, two products. So they had x plus 2 in common. So this was taken out, and then what is left plus what is left from the other one. So now we finally get to these special products. There are 4 for binomials. Here they are. A squared minus b squared, a squared plus b squared, a cubed minus b cubed, and a cubed plus b cubed. You have them on page 2 at the top, and we'll fill them in a minute. Okay. Say it again.
What was 4?
Negative leading coefficient. We have to factor that too. And then special products. Okay. So this was one of our agreements, or it was mentioned in our first agreement at the beginning of the semester. Not in this form, but in this form. So we wrote something here such that this factored form was giving us this. But now, because we learned it, now we're going to go backwards. We're going to start with the binomial, and we're going to write the factored form. On the agreement, we had the factored form, and we had to come up with, that's how we used it in rationalizing the denominator, and that's how we used it in dividing complex numbers. So what does this equal to? Thank you. Extremely important. And this is called the difference of what? Squares or perfect squares? That's okay, the same thing. So difference, so this is called difference of perfect squares. So see how important this formula or special product is. We use it both ways, from here in 2 applications, and from here in another 2 applications, solving the equations and chapter 7. Good. Now, how do you think we're going to call this one? If this was the difference of perfect squares, how do we call that one?
Sum.
Very good. Sum of perfect squares. Well, this is not factorable. To be exact, to be correct, I would say it's not factorable using integers. That's the correct sentence. In short, we'll say not factorable. So not factorable. I will put in parentheses using integers. Now, your book says that this is prime. I'm not fond of that name, but I accept it. You can say it's prime. However, I prefer not factorable. But it's up to you. Now, how do you think we're going to call this? So this is, Becky, this is the difference of perfect squares right here, this one. And this is the sum of perfect squares, which is not factorable. What is the name of this and this? Of course, difference of cubes and sum of cubes. Perfect. We have not encountered these two before, so we have to talk about them. So for now, on the form, if you have it, I would like you to put in here a squared minus b squared being a plus b times a minus b. And here, write not factorable or prime, whatever, I accept both. And now we are talking about these two. Okay. So when we want to factor the difference of cubes, we will factor using a binomial times a trinomial. So once again, this does not mean that we reached the trinomials or the strategy for trinomials. It only means that when I factor difference of cubes, I have to have in mind a binomial and a trinomial. Let's address the sequence of signs first. If I factor the difference, then the binomial has to have the difference, but the trinomial will have the sum. Of course, the last one is always positive. That's why I don't even mention it. Now, a wild guess from you. If we factor the sum of cubes, what should the binomial be? Sum or difference?
Sum.
Of course. And what should be the middle?
Sum.
Difference. Because these four terms have to go away. We're gonna work on one of them in a minute. Okay? So the sequence of signs is minus, minus, plus, or plus, plus, minus. And I don't even discuss the last one here, it's always positive. Okay. So now I'm going to ask you to help here for a second, and I'm going to ask, what should I write here that I raise to the third power to get a cubed? I know it's a silly question. What should it be? A. What do I raise to the third power to get b cubed? Good. Now this is something we talked a lot about. It's not the same formula, and it does not have 2 in the middle, like the one that I tortured you with for 2 months and a half. So, but the idea is the same. I square this and put it here. I square this and put it here. But this middle one is just the product without the 2, which is a trinomial, which is a different story. So I have a squared, ab, and b squared. So you can say, yes, this is the formula, but when I apply it, it will be more difficult. Yes, it will be, but we will practice it right now. So let's look at one or the other. Which one would you like to check? You would like to check the first one with minus plus plus, or the one with plus minus plus? First one? Okay, very good. So let's just check. Good. So I have a binomial times a trinomial. How do I multiply them? I distribute a to a squared. What do I get? A cubed, very good. Then I distribute A to AB. What do I get? B, very good, plus A multiplied to B by B squared. I get AB squared. And now I have negative B times A squared, which is negative A squared B. And then negative B times positive AB, I get negative AB squared. And then negative B times B squared, which is negative B cubed. Would we agree? We agree with the product. Is that a yes?
Yeah.
No?
Yes.
Good. Okay, so now look at what happens. What should the answer be? What should the answer be? Right. So 4 terms must go away. Let's see if they go away. What about positive A squared B with negative A squared B? Gone? Agreed? What about AB squared with negative AB squared? Gone? Yes. So the answer is indeed A cubed minus B cubed. So this is not a proof, but this is just checking, right? So every time I'm factoring a difference or a sum of cubes, I have to have a binomial times a trinomial. The trinomial will be similar to the formula for something else, but not the 2 in the middle. Okay. So this is the entire strategy for binomials, and now let's go through these examples. So let's start with 4z squared minus 25. I have to go through all these steps. I cannot jump, because if I do jump, in certain situations, I make my life more complicated. Okay. What type is it? Binomial. Is it in descending order? Yes, it is. Does it have a greatest common factor? No. 4z squared and 25 do not have a common factor. A negative leading coefficient? No, no negative leading coefficient. So I'm down to special products. That's the last question I have. Okay. Is there a special product applicable here? So I have 4 special products. 1 I shouldn't even discuss because, actually 2 I shouldn't even discuss because they're not sum. They're sum, and so that this is a difference. So I'm basically debating with myself between 2 formulas, either the difference of squares or the difference of cubes. Which one is it? Sometimes it can be both. And I can show you an example in which it's both. But which one is it now? Obviously 25 is not a perfect cube. So yes. So I'm expecting two perfect squares. So this is what? 2z, and this is 5. So then I know the formula for the difference of squares. And what should I write? What should I write?
Z plus 5 times 2z minus 5.
Exactly. That's it. Two z plus 5, 2z minus 5, and you know that the order is not important. I can have 2z minus 5 times 2z plus 5. It doesn't mean that it's a different factor form. It's the same. Very good. X to the 4th minus 81. When I'm asked to factor, I'm asked to completely factor. Okay. I go through all the steps quickly in my head. It's binomial, it's in descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product. Is there a special product? Again, I'm debating with myself between 2 formulas or special products. The difference of squares or the difference of cubes. But I know 81 is not a perfect cube. And x to the 4th is not a perfect cube. And the degree is 4. So a degree 4 cannot be changed into perfect cubes. So which formula am I thinking of then? Good. So is this a perfect square? Is this a perfect square? And if yes, what do I have in there? So what do I have? X squared indeed is x squared and 9. Good. So now I know how to factor it. What should I write? Yes. One is plus and one is minus. Good. Now which of these two cannot be further factored?
Negative 9, or the x squared plus 9.
The x squared plus 9 because it's a sum of squares. So no one can do anything to this. But this is that further factorable? The answer is yes. How?
X minus 3x plus 3.
Very good. X plus 3, x minus 3, x squared plus 9. And now this is completely factored, fully factored, and no one can do anything else.
Why couldn't you do that with x squared plus 9? So you just do redundant.
Right? It's a sum of squares. No one can factor that using integers. You could, but not integers. And I can show you, but we normally don't do this. There is no need. In special cases, maybe, but. So I can factor this into x plus 3i and x minus 3i. But that's not the point here in chapter 6. We are only trying to factor using integers, not irrational numbers and not complex numbers. Even, for example, x squared minus 9. I'm sorry, minus 3. I meant to write. Even this one is factorable. And you can say, how come? 3 is not a perfect square. How can you factor this? And I can, which is x plus the square root of 3 and x minus the square root of 3. But this is not what we are trying to do in chapter 3, in chapter 6. Okay? So we're only trying to factor using integers. These are not integers. These are not integers. They are irrationals, right, from chapter 10. So this is not required for you to do. Okay, y cubed plus 8. I go through the first 4 steps quickly in my head. It's a binomial. It's in descending order. No greatest common factor. No negative leading coefficient. No special product. I'm sorry, no negative leading coefficient, special product. And again, I'm debating with myself, which one is it? Is it the sum of cubes or the sum of squares? Well, if it's a sum of squares, there is nothing I can do because the sum of squares is not factorable. So now, is it the sum of cubes? If you say yes, then we'll have to get ready a binomial times a trinomial. Will you say yes to the sum of cubes? Yes, you will say yes to the sum of cubes. Now we have to identify A and B. What do I cube to get y? Let's establish the sequence of signs first. That's to be safe. What will be the sign here? What will be the sign in the middle? Right, because if I don't have a minus somewhere, the terms will not go away. If everything is positive, then I will have 6 terms, not 2. So that's why it's plus, plus, minus, or minus, minus, plus. Good. So what should I have in the binomial? Very good. And this one should not be difficult. You square y, and you put it here. You square 2, and you put it here. And this is just the product, not the 2 times the first times the second. That's a different formula. So it's just 2y. Let's say you have doubts. Let's say on a test you say, I don't remember this. How will you check? For sure. You know, I kind of remember it. How will you check this? Just go back and multiply. Y by these 3 terms, 2 by these 3 terms, 4 of them have to go away, and you're back to y cubed plus 8. Is this okay? Yes? Okay, perfect. So next one. Before I forget, I want you to, between now and Tuesday, page 411 and 412, I know there are 100 problems there. I'm not asking you to do 100 problems. I'm asking you to do at least 25 odd number problems. But I recommend do this. Do 1, skip 3. Do 5, skip 7. Do 9, skip 11. Do 13. That's roughly 25. And check the answer in the back. If you don't get the answer in the back, then we need to come back and practice some more. Okay? And this contains everything that we're going to cover today when it comes to factoring only, put in 1, 2 pages together. And they will not be in any particular order. So you may be surprised from one problem to another what you're getting. Okay? So please work on that and so we can do this together. Okay, next problem was -1/16 plus x to the 4th. So then, it's a binomial. Is it in descending order? No, it's not. So I have to rearrange it. Greatest common factor? None. Negative leading coefficient? No. Special product? I always hope for a special product. Again, I'm debating with myself between 2 formulas. The difference of squares or difference of cubes. But the degree is 4. There's nothing I can do with degree 3 here. So I'm expecting then 2 binomials. If it were difference of cubes, then I would have thought of a binomial and a trinomial, but that's not the case here. So now, how do I factor this? Very good, excellent. One of them, there is nothing I can do. We're using integers. I gave you a couple of examples in which I can. But using integers, one of them I can't do anything. And actually, I should have also said also rational numbers are possible. Like here, 1/4 is not an integer, it's a rational number. So then, x squared plus 1/4 cannot be further factored. It's a sum of squares. But I can further factor this. And how? Very good. X minus 1/2. Perfect. 1/27 minus x to the 3rd. It's a binomial. It's in descending order. No. I have to rearrange it. Greatest common factor? No, but it has a negative leading coefficient. Be careful. Your book does not do this. Your book does not factor out the negative leading coefficient, and it's possible that my LEPS Plus does not factor a negative leading coefficient. But then in chapter 7, they say, oops, we should have done that in chapter 6. So I can do that to you. So the leading coefficient, if it's negative, has to come out as a factor. Okay? Because if you read the book, when they get to chapter 7, they say, oh, we're really sorry, we should have taught you that from chapter 6. Now you're changing the whole thing again. I can't do that. So I have to factor out the negative leading coefficient. For many, many reasons that you will see in chapter 7 and beyond. Okay, now what? What is left in parentheses?
X minus 1/3.
Very good. Right? X cubed minus 1/27. Is that clear? Negative 1 times x cubed, and negative 1 times negative 1/27 is positive 1/27. Now I'm debating with myself. It's a difference of squares or the difference of cubes. If the degree is 3, difference of squares have nothing to do with this. The difference of squares has nothing to do with this. So it must be difference of cubes. In that case, I have to have a binomial and a trinomial. The sequence of signs, I'm factoring the difference. What should I have here? Minus. And here in the middle? Perfect. Now I need to identify the binomial. Which binomial will work here? Do you all agree with x minus 1/3? X cubed is x cubed. 1/3 cubed is 1/27. Do we agree? Okay. And now can anyone come up with a trinomial? Very good.
Plus 1/3 x
Yes?
plus 1.
Very good. I have to square 1/3. 1/3 times 1/3 is 1/9. Perfect. Okay, last one here. X squared plus 16. What do I do with this? Nothing. Very good. I agree. Not factorable. It's a sum of squares, which is not factorable. Using integers or rational numbers, I should say. Very good. Okay, we're moving on to trinomials. Factoring trinomials. 1, 2, 3, and 4 are the same. Same. 5, special products. But as you know, we only have 2 here. I've been torturing you with those for a month or 2 months and a half, almost. 2 months. Because we have another month and a half left. Okay, what are they? Of course, we discussed them this way, but now I want them this way. So this is in the past, and this is now. And here's the second one. There are only 2 special products for trinomials. And we have them in our agreement. So what was equal to this? And what was equal to this? So I'm hoping that you put in there the difference of cubes and the difference of the sum of cubes on the handout. I'm hoping you put that in here and here, and we are here. And I will work on these examples in a second, but I want to finish the strategy first. Anyone? We've been working on this for 2 months. But from here, yes, what do I have? Very good. And here? Very good. We know this because we've been reviewing it for 2 months. But now we're using it. That's why I wanted you to remember it as a formula and not continue to FOIL, because now we're going this way. And this is way more difficult than going this way. Okay? Ready? Okay, there is strategy number 6 and there is strategy number 7. If this fails, then we have 2 more chances. Okay, here's the first chance. And here's the second chance. The last one, number 7, is the most difficult one. And this is the one that we discussed right before the test, if you remember. And we'll go over it again. Okay, so let's start with trinomials. But first, let's look at these 2 simple examples in which we only factor the greatest common factor. So factoring trinomials is the most difficult one. First of all, look, I have 7 possibilities here, or 7 questions, or 7 steps. Okay? We only had 5 in binomials. And in polynomials, we'll have also 5. This is the longest one. I have so many different situations. Okay, so let's start with the first 2 here, in which I have x squared y to the 4th minus 2xy to the 4th plus 4x cubed y to the 6th. I'm asking myself, what is it? And the answer is, it's a trinomial this time. I'm asking myself about the degree and if it's in descending order. So degree of this is, very good. Degree of this is 9. So what is the degree of the entire thing, the entire polynomial? You're not adding the degrees, you have to choose the highest now. I'm adding exponents of variables in each monomial, but when I decide this whole thing, this trinomial, I have to choose the highest degree, and that's it. So it's degree 9. So that's why I will rearrange it as 4x to the 3rd y to the 6th, and then degree 6 is next, plus x squared y to the 4th, and then minus 2x y to the 4th. So I go through my strategy. What is it? The trinomial. Is it in descending order? Now it is. Greatest common factor? Yes. Negative leading coefficient? No. So what is the greatest common factor? Something that is present in all 3. Is anything present in all 3? And x is at the smallest power, 3, 2, and 1. And y to the 4th, for y, the smallest power is 4. Excellent. How many terms will I have in parentheses? If I start with 3, I must have 3, no matter what. Because otherwise I will not be able to recover. If you want to distribute, if you only have 2 terms here, you'll miss 1 term. 1 term will disappear. Okay, very good. So now what? I need 3 terms. This multiplied by something is this. So definitely a 4, and definitely x to the 2nd. Very good. And definitely y to the 2nd. That's it. Plus. This is power 2, so I took 1 out, and power 4 is out. So plus what? X. Good. Very good. And then finally minus? 2. Minus 2. Do we all agree with this? Yes, everyone? Okay, perfect. So let's look at one more, and then look at special products. So we have 2x squared minus 4x, 2x squared minus 4x plus 6y cubed. I go through my strategy step by step. And by the way, we cannot factor any further here. We cannot do anything. So it's in not in descending order. The degree of this polynomial is, and you can say, why do I really need to identify the degree? Everything depends on the degree of a polynomial after this class. We will talk about one of them in chapter 9. No, in chapter 11. All the rest of the polynomials will be dealt with in the next class. And you will see how important the degree is. So indeed, degree 3. So then I have to rearrange it as 6y cubed plus 2x squared and minus 4x. It's in descending order, negative leading coefficient, no, but it has the greatest common factor. What will you pull out from all 3? You cannot pull out from 2. Yes. What else? 2x. What is left in parentheses? How many terms would you write in parentheses? Of course, we have to have 3. Because I start with 3, I have to have 3 in parentheses. And I have, oh, I'm sorry. Oh, I copied y. I'm sorry. I'm sorry. I'm sorry. I'm sorry. I talk too much, I know. Sorry, sorry, sorry. Okay, so I have 6x cubed plus 2x squared minus 4x. Perfect. So now X is in common, and 2. So I have left what?
3x
Squared, very good, plus, very good, minus,
minus 2.
that's it. Very good. So now finally let's move on to page 3 of this handout. So at the top, I'm hoping you already put in a plus b quantity squared here, and a minus b quantity squared here. Becky?
Got it.
Yes. It's right here. Yes. So if a squared plus 2ab plus b squared is this, and this. We have a contract on both. Okay, ready? So we have y squared plus 121 minus 22y. Please do not skip steps. Till you learn this strategy very well, do not skip any step. So I have to go through all these. What is it? It's a trinomial. Is it in descending order? The answer is no. So I have to rearrange it as y squared minus 22y plus 121. Now it is in descending order. Greatest common factor? No, there is no greatest common factor. Negative leading coefficient? No, there is no negative leading coefficient. So now I am down to special products. When I get to special product, in my mind I say this. Is this a perfect square? Is this a perfect square? And for a moment I ignore this. Yes, so what do I have here? What do I have here? 11. So what do you expect to get? Because remember, there are only 2 special products for trinomials. What do you expect to get? Based on these 2 formulas at the top. First of all, this middle term is negative. So the formula has to have minus, right? This binomial has to have minus. What do you expect? Exactly, that's what I expect. However, notice that I covered the middle term. So I have to check the middle term now. What will be the middle term in this expansion? Now it's a different formula. Now it has a 2 in the middle. So 2 times the first times the second. What is 2 times y times 11? Of course, negative. Negative 22y. Now I check. Is this negative 22y? So then I will say this is it. It's the correct factor form. What if I say to you now, please factor this? What will you say? Oh, that's easy. Right? It will be what?
What is the problem?
Just wait 1 second. So what should the factored form be?
Y plus 1.
Y plus 1. But what is the middle term here? What do I have on the left? So this is definitely not the factored form. That's the point I'm making is no matter what you do with the first and the last, and you assume blah, 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 if you don't check the middle term, you may not get the correct factored form. So be very careful. Simply looking at the first term and the last term, it's not guaranteed that you come up with the correct factored form. You still have to check the middle term. You cannot disregard that. See here, this middle term should have had a 2, but it doesn't. So I cannot assume that these 2 are equal because they're not. Is this clear? Okay. Next problem. A negative 3x squared. Becky, is this clear now? Okay. So negative 3x squared minus 12x and minus 12. Do not omit anything from the strategy. So it's a trinomial. It's in descending order. Negative leading coefficient, yes. Greatest common factor, yes. So what will I factor out? The negative leading coefficient has to come out. It's mandatory. Exactly. Oh, I don't know why. Please do not put two negatives in there. You're very powerful today. Somebody said, was it Jackie? Becky, you said -3? You're very powerful today. Or somebody, whoever said -3, I just, don't tell me to jump. Because I may be able, or you may have that power. Okay, so, -3 out. What is left in parentheses? How many terms? Exactly 3, because we started with 3. Perfect. So what are those terms?
X
Very good.
plus 4x
Very good.
plus 4.
Excellent. So now, I'm asking myself, is that a perfect square? Look at the first term, look at the second term, and come up with an assumption. What is the assumption?
X plus 2.
Yes, the assumption is this. However, it's not 100% till I check what? The middle term. What will be the middle term in this expansion? 2 times x times 2, which is 4x. Do I have 4x here?
Yes.
So that's correct then. Okay, x squared minus 4x plus 4. Yes, it's a trinomial, a descending order, greatest common factor. No, negative leading coefficient. No, special product. Yes, I just got it a second ago with a plus. Now it's with a minus. So what will be the factored form of this? Is that clear? The middle term will be -2 times 2, -4x. And the last one, 6a plus 9. Descending order, it's a trinomial descending order, greatest common factor. No, negative leading coefficient. No, special product. I always hope for a special product. It's so much easier. If you look at the first term and the second term and the last term, you will conclude, bless you,
Thank you.
a plus 3. Let me see, I think it's on dorm, but yeah, it's maximum on dorm. It's a corner room. Have we checked the middle term?